afternoon, everybody. My name is Russell Lawley. I'm a geologist based here at the British Geological Survey. This is not the first time I've presented to some of you, I'm sure. What I'll do is I'll take you through a whistle-stop tour of the British Geological Survey's products that you can access through the Roam service and also download via Digimap, basically. Happy to take questions at the end. And the questions can be about anything. It doesn't have to be about this presentation if you want. I'll happily do a jobbing geology job as well if you want at the end. So here we go. Let's dive into this. Okay, so there's quite a lot of data available via Digimap. On the left-hand side, we cover our basic geology maps, which I imagine is what most of you will use. Various scales are available. We'll go through some of these so you can see what they look like. We have some additional, not necessarily straightforward geology content as well. So hydrogeology, soil parent materials, permeability, and radon are in there. I'll talk a little bit more about radon because it's been quite important to BGS over the last 12 months. But not available on Roam, but available for you to download and use things like superficial deposit thickness, geocoast, and also there's some further information about onshore boreholes and the lexicon of named rock units. So there's basically the rough list of what's available, and you can access these. If you have any issues with any of these, you can get in touch through the help at Adina, or you can just contact BGS anyway and just say, I need some help with why can't I see this, that, and the other. Okay, so I'll get straight to the data set where most of our fieldwork information is based. So this is the BGS Geology 10 and 25K maps. Current version is version 2.18, which is the version you have on Roam, and they are actually two separate data sets. There's the 10,000 scale data set and the 25,000 scale data set. They will be merged imminently. I've been promising this now for 3 years, but I am told that we are imminently about to launch version 3.24, which is 10 and 25K merged together, which will cause a few headaches for people who've got to program this. Each data set comes with a bedrock layer, a superficial layer, linear features, artificial materials, and a mass movement layer. And that five-fold structure is how we break up our data. The bedrock layer is anything which is a lithified material more than 2.6 million years old. Superficials are anything from the Quaternary age. Linear features, artificial materials, and mass movement kind of like speak for themselves. They're specialist layers detailing specifics. Ultimately, when we release version 3.24, we will start looking at version 4. So the reason why we've got these works in progress is we have an archive of paper maps, which we are very, very slowly crawling through. And ultimately, we'd like to try and have full coverage for the UK, but I think I'll be long retired before we get there. But we are planning for a version 4, and it will mop up some other areas that we know we've got available. They're just not quite ready to go digital just yet. 10,000 scale and 25,000 scale is our field scale. So when I go out and map, I map at 10,000 scale, unless I'm in parts of Wales and Scotland where I might cheat and use 25,000K. It is our highest resolution mapping. It is the kind of data you're probably going to look at if you're studying geology yourself or geography and you want to see what did we see in the field. You can go and look at this data set and you can try and work out from there how we've made the map, basically. The layer that most people interact with is the BGS Geology 50,000 scale mapping. So this is currently version 8.24, which was published in 2017. My team is currently working on version 9, which should be available in the first quarter of 2024. We might have a few delays, unfortunately, but we are going to try and get it out at the beginning of 2024. Again, it has a 5-layer structure: bedrock, superficials, linear features, artificial, and mass movement. This data set has near full coverage. There is one tiny grey square called Knighton on the English-Welsh border, which is a source of unending embarrassment for BGS, but we have finalized the mapping of that area. It was supposed to be sorted out this year, but unfortunately COVID got in the way. So we are running about 12 months, 18 months behind that one. When we release version 9, we hope to have a revised fault database. So the faults have gone from being a purely cartographic thing, a line that you just look at, to having a little more content to them. We may have the unconformity database in there as well. We've struggled with that one a little bit because it's quite difficult to manage that data. Night and sheet mapping is ongoing. Love to get it finished, then I can finally say we've covered all of the UK. What we will have done by version 9 is compiled a whole load of corrections for at least 35 geological sheets. So you might not spot the difference, but there are differences in the map. So it's worth having a look when it comes out, basically. I'm not quite sure how quickly we'll get it to Adena to get it uploaded, but they're pretty fast at uploading these things, and we like to get things into Adena as soon as we can so that everyone can see what we're already hosting on our own website. So Adena is one of our priority outlets for this. So we'll do our level best to make sure you get it as soon as we've got it published. BGS Geology 250 is an unusual one in the fact that it's my favorite scale. As a jobbing geologist, I use the 250K geology onshore and offshore practically every week. It's a nice, handy data set for doing regional studies and regional analysis. You will all be using geology data for different reasons. So you may be doing a geology degree, you may be doing some research. The 250K data set is a very unsung hero in my book. It's just handy for having just enough spatial interest to do some really good regional statistical work. So if you're looking at epidemiological work or you're looking at social deprivation indices, it's a handy data set to say, okay, I need a spatial domain where I can start analyzing some statistics. 250K kind of like works for me, and it's why I use it a lot. We have been reviewing it now for a couple of years. It is quite old, so it was made in 2004. It's based on some paper maps that were made in the 80s and 1990s. Ultimately, what we're aiming to do is to utilize the 50K data set as the source material rather than have a separate paper archive for this data set. So there will be a new bedrock layer and there will be a new superficial layer. So the onshore 250K doesn't have a bedrock layer, doesn't have a superficial layer, it only has bedrock and linear features. So one of the things we do want to do is improve the superficial cover, which I think will make it even better for regional studies. And we'll also include a new fault database as well, because that will be great for people who want to do regional studies of structure. The marine bedrock and seabed sediments and the hard substrate layers. Now, these are very, very popular with all kinds of sectors, and they have been for at least 20 years now. They remain popular with wind farm projects, power interconnectors, and marine aggregate companies. So we have a regular flow of queries about these data sets. If you are studying in a marine environment, they act as a great baseline for looking at features. Rome doesn't include any higher resolution data than 250K. But if you've got a study where you need to look at something high resolution data does exist, you'll just have to come to BGS or go to another party to provide it. But these layers are brilliant if you're doing some kind of regional overview in the offshore or wider UK economic zone, which does extend quite a long way offshore. We actually trim the map down. There's a little bit that extends off to Rockall as well, but it always makes the slides look a bit ungainly on PowerPoint. So there's quite a lot of information in the marine bedrock and seabed sediment that we are trying to review again. They evolved over time. Like most paper maps, they kind of like have like a timeline of development. We are looking to renew the 250K data sets, but we will do that again on the basis of some finer scale resolution mapping that's available, which is backscatter and bathymetry based. So you'll have to look out for those. I don't have a timeline for those just yet, but they will be getting updates. And then the one that I think is probably used most, it's certainly our biggest download, is the BGS Geology 625. So this is the freely available data set. This is the vector data that everyone downloads from the BGS website. Obviously, you can download any of the stuff that I'm showing you today, but mere mortals only get to see this layer online for free. This has proved popular for as long as I've been studying geology, since the 1980s. It's only been vector, I think, since about 2001, but this map in some form has been around everywhere, basically. I've seen this map appearing in movies and in different parts of the world wherever I've gone. It's a great map to do national overviews, a bit like the 250. It's possibly a little too simplified if you want to do regional statistics, but if you want to do national statistics, it's great. If you just want some eye candy during the presentation, again, it works really, really well. We have been trying and experimenting for at least 15 years with automatic ways of rescaling our data. I think we're on our 4th attempt to create a 625K scale superficial model using 50K data. We still haven't got it right. I know that there's an AI team here at BGS who are itching to have another go. I'm a little bit old-fashioned, and I would just like to hand this map over to one of my cartographers and get them to draw it by hand again. But we will probably try again with AI and come up with a new GB superficials layer. We'll need to anyway, because the current superficials layer is based on the 1977 paper map. We have moved on since then. So we do need to do something new in 2024 with this layer. So again, you have to watch this space. As soon as we've got it ready, Adina will be one of the first places we'll make sure it's ported to. Around about 24, 25 years ago, I was packed off as a young geologist to go and talk to Cranfield University about making new soil maps for Great Britain. And we started work on a DEFRA project. The outcome of that work was the BGS soils outputs. Now, it's not strictly a soils map, it's what we call a parent material map, which is a geology map by a different name. So it's a geology map that describes things that soil scientists might understand. If you are studying geography or soils or environmental science, then this is a really useful data set to go and have a look at. Yes, it looks like a geology map because it's based on the geology map, but it talks about the kind of information that you might expect to see on a soil map. So we will provide descriptions of texture. I think there's at least 2 or 3 ways of describing texture in there in terms of simplified classifications. So the soil texture in at least 2 ways, and then soil group is the DEFRA classification of heavy, light, medium soils. There's a little bit of soil chemistry in there. I am currently working on version 8. It is not going to come out next year, unfortunately, because we're having to cover so many backlogs to do with COVID. So I suspect version 8 will come out 2025. But you can certainly look at this in Rome. You can certainly play with the data. If you need a bit more information, you can jump across to the UK Soil Observatory or just come back to me at BGS, and you can go and look at this data and have a play with it. If you do jump across the UK Soil Observatory, there are 200 layers of soil information. I would love to get all of those into Adina, but I'm pretty sure the Adina folk have got more than enough data for now. But if you have any questions, feel free to come back to me on this. The importance of geology and soils together is it gives you the interface between the subsurface and the atmosphere. So if you're doing any kind of biodiversity analysis or landscape or land use analysis, it's a good idea to have a look at the soils layer rather than just relying on the geology. Over on the right-hand side is a product that we first made, I think it was 2003, so it's 20 years old this year. The version that you're currently looking at, version 5, was actually made in 2010. This one has been in, I think Hollywood calls it development hell, for over a decade now. The first model was brilliant in the fact that we managed to make it with a lot of effort. It was flawed in the fact that the model had a lot of expert judgment. We were using some fairly antiquated ways of making it. And so the new version, which I am hoping comes out next year, has a new interpolation method. It's got 10 whole years of extra borehole sessions in there. It should have a nice new shiny uncertainty model in there. It should be based on our version 8 geology map, which is why we'll call it version 8. And it builds on over 10 years of trying to improve on something without breaking what we currently have too much. There is a freely available summary model, but you can access the 50K version. There is also a separate buried valleys model. So if you are interested in paleo valleys of the Quaternary period, you can have a look at this in Rome, have a look at the areas you're interested in, and then you can go and Google buried valleys by BGS. And there's a whole separate data set you can freely download and have a play with there, which looks at these very strange potential aquifers of depth scattered across parts of Scotland and England and Wales. Again, there's a lot of work going on with this. It is used quite a lot by industry. It is basically the depth to bedrock. So in some parts of the country, you've got 156 meters of quaternary material. This is unlithified, unconsolidated material. For engineering purposes, you need to know where you've got these thicknesses. So although the model has flaws, it provides a good overview of the paleo landscape of Great Britain. So again, if you're looking at history of evolution of the UK landscape, having a look at this layer and the rockhead layer, excuse me, would be really useful, because you get to see where paleo rivers were, where areas were substantially lower elevation than they currently are because there was no material there, where ice valleys have been scoured out, etc., etc. So it's a great little data set, love it to bits. It's one of those which is really good if you're looking at 3D modeling as well. If you're doing any kind of 3D work or landscape analysis work, it's a handy model to have in the background just to have a look at how things were. Hydrogeology is another one of our older maps. It's a 625K scale model, so 625,000 scale. I do apologize, those are appalling colors on a low contrast screen, so I do apologize if you can barely see those. This has been around since the very early days. It was originally a paper map. The paper maps are still in demand, but we no longer make them. It's a really simple classification of the productivity rating of the aquifer. Basically, it's a major aquifer or a minor aquifer, whether it's productive or not. There's a description for flow mechanisms, so matrix flow or fracture flow. There is a main rock description, so the bright green is obviously the chalk aquifer. You can see the blues, the dark blues of the Triassic aquifer in there as well. And there is a generalized aquifer description. If you're a hydrogeologist wanting a simple overview for the UK, a great map to go and play with. If you're studying geology and you want to understand water as a resource in the UK, again, it's one of the layers that's really handy to bring up on Rome and have a little scoot around and have a look. This layer probably needs a bit more work, if I'm being honest, because it's quite old. But again, it's one of these data sets that just works. It's of the right scale for what most people want to do. Most people who are using this data are doing the regional study, so they might look at, say, the Yorkshire Water area or the Severn Trent area or the Anglian area, or they might be doing the regional resource study for Wales or Scotland or England. So it works at that purpose. If you need something with a bit more bite to it, with a bit more detail, you're going to have to come back to BGS for that. But there are some additional data sets that you can find if you really need a bit more detail. Related to the hydrogeology, on the right-hand side is the permeability data set. I think this only went into Rome last year, so I'm not quite sure if we actually talked about it last year. So what it says on the tin, basically, we describe the min-max permeability and then the flow type for each geological unit that you can see on the 1 to 50,000 scale geological map. So there's a description for min-max permeability, flow type, matrix or fracture flow, or a combination of the two, and then a basic description of bedrock and superficial units. We also do a model for anthropogenic deposits, but I'm not sure that's available on Rome. The reason why we do this is that the propensity for water to move through our landscape is quite important for a lot of other studies. So this baseline permeability data feeds into information we give to the utility sector. It feeds through information we give to water companies. Certainly the EA have access to this data set in terms of water regulators. So if you are, again, if you're a hydrogeologist and you're doing some kind of regional or local study, because this is 1 to 50,000 scale data, you can start to understand where you might have flow paths, where you might have aquitards and things like that. It is a very jazzy map. I couldn't quite replicate the colors on Rome, unfortunately, so I went for a blue-purple combination, because who doesn't love blue and purple on a map, basically. You obviously, once you download the data, you can do what you like with it, but the important thing to bear in mind is that there's quite a lot to think about in this. This is probably a step beyond the standard geology map, where you slap the layers together and it makes a pretty picture. This one you have to think about, if you think about the superficial thickness model, we are describing the permeability of the surface superficial deposits and the surface bedrock deposits in the context of a 3D world. So there's some complexity in there. You have to think about it. So this data set's not for the faint-hearted, makes a great picture, but you do have to think about how you might want to use it if you've been tasked with some research. It works well if you're also looking at the borehole data set, which I'll come to in a couple of slides. GeoCoast is one of your downloadable data sets. You can't see it in Rome, unfortunately. It is a data set that I would imagine geologists, environmental scientists amongst you have actively looked at and gone and downloaded and have a play with. Because you can't see it in Rome, it's possibly not so visible to you. You may not be aware of it. There's multiple tiers of information within GeoCoast. The original idea was to provide some kind of additional information for shoreline management plans, for local authorities and for the Environment Agency, to try and help them understand coastal regression to do with landslides. There's been a lot of issues with landslides, and I'm going to put my health and safety hat on. If you are out and about as a student or a researcher, please, 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 please keep away from the cliff edge. I am so tired of getting into rows with people sunbathing at the bottom of cliffs. Really, 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 our UK coastline is nowhere near as stable as people think it is. This map is evidence for that. As you can see, there are various types of coverage. So there are some statistical metrics for local authority-based data, so you can analyze susceptibility to erosion, inundation, groundwater flooding, all relating to the coastal zone. There is a ribbon map which goes all around the UK. The ribbon map is interesting, certainly for the geologists who are in the audience, because the erodibility is based on the geology at the wave cut platform, but also the 3D stack of the cliff that might be above the wave cut platform. So there are kind of like factor analyses in there which involve the entire cliff, not just some 2D flat earth analysis of what might be going on at the coast. It's worth having a play. We'd love to talk to more students and researchers about improving this data set. It's here really for the research world to go and have a look at and tell us what they think we could do with it to improve it. EA and various engineering companies already use the data. We're hoping it'll get built into some further EA products relating to coastal erosion and coastal defense. Quite an important data set. It's had a very busy year because of quite a lot of infrastructure comes onshore and offshore as we relate more and more wind farms and more inter-country power connectors. Understanding how the shoreline behaves is really quite important. If you're researching that, it's a good choice for a career. There's an awful lot going on in this very dynamic environment. Our coastline has suffered from underinvestment for many, many years. We are going to have to do something about that, basically, because we have an awful lot of issues in our coastline that we're going to have to redress if we're going to enhance and preserve the environment that we have there. I'm now going to briefly talk about radon. I'm going to do a quick time check on this. Okay, am I doing okay for time? So radon, I think, joined the party this year. We only published the map on the left back in December. We had a last-minute glitch in the fact that the Cabinet Office were busy with other things last December, so we almost failed to get permission to publish this. Radon's an odd one to include because an awful lot of people have no idea what it is or why we've included it. Radon affects everyone. All of the people on the call, it affects me, it affects everyone we know. It's a geogenic gas. It's a noble gas, so it doesn't react with many things. It's colorless, it's odorless, it's heavy, and because it's a progeny of uranium, it occurs in all rocks and soils. The reason why radon is of interest to BGS is we've just published a new radon model, but we have been publishing models now for at least 25 years. The reason why it's become a hotter topic is to do with energy crises and climate change. So what's happened in the last 4 or 5 years is that house builders have got much better about insulating homes. So we no longer have some of the worst housing stock in terms of design and build. We have some really, really smart, clever houses which are really, really efficient at keeping in heat. Unfortunately, they're also really efficient at keeping in radon, and radon is a health hazard. So if you have been lucky to be involved in a house purchase or sale in the last 12 months, you may have seen the radon question pop up in the housing documents, the house details. So 50% of your radiogenic exposure in a year is down to the radon, which is naturally occurring in the rooms that you're currently sat in. It's a good idea to manage it. There is an association with lung cancer, and your risk of lung cancer obviously increases with smoking, And the other factor why radon has become an issue is that as fewer and fewer people smoke, I know we've swapped it with vaping, which brings a whole host of different health issues, but as fewer and fewer people smoke, we've realized that there's an underlying trend for a certain percentage of people who don't smoke and don't vape and live ordinary healthy lives still going down with non-genetically related lung diseases. And radon is the smoking gun as far as we can tell at this moment in time. So there's 1.1 million house sales a year now that point to radon. Radon is specifically covered in BR 211, which is the construction Bible. But also radon features in 4 areas of UK legislation, including the Health and Safety at Work Act, and including ionizing radiation regulations and the Housing Act. So the health and safety message and the public sector message that I'm giving today is if you're in rented accommodation or if you are renting accommodation out to people, you do need to think about radon in some parts of the country. It is associated with certain rock types. Everyone knows about granites in Cornwall. Everyone knows about granites in Aberdeen. But actually, all rocks and soils can emit radon. And if you look at the darker areas on that map on the left-hand side, I'm hoping the geographers and geologists in the audience will completely spot inferior oolite, Northampton sandstone, Derbyshire dome, all kinds of interesting rocks in there. Traditionally, the old map for radon back in the 1970s just showed a blob on Cornwall and a little bit around Aberdeen. This is a fairly heavily structured source pathway statistical model, source pathway receptor model. UK HSA, Health Security Agency, provide information to us about 560,000 indoor measurements. We throw some statistics at that to look at how they relate to geology, and then we make a map. We don't actually get to see where those measurements are taken because of GDPR, so we deploy some funky statistics to make it all work. Have a think about what it means to you. Go and have a play with the data, because what we need in 3 or 4 years' time is a new tranche of geoscientists and statisticians to come along and make the next version for us. So again, this is a research topic that people should be looking at. Boreholes in the BGS lexicon. So these are basically services that we provide straight from BGS. You can access some of this content through Roam, I believe. Over 1 million boreholes in our database. If you're doing anything where you're looking at the landscape, you want to know, well, what's under the land, the borehole archive is freely available. It's click and play. If you've got a scan, feel free to go and have a look, work out what the 3D geology under your feet is. The lexicon is really important because all of our geology data utilizes the lexicon. So if you want to know what a rock or deposit is called, start at the lexicon. That'll give you the lithostratigraphic name, a brief description of what it is. If you need a bit more detail about the lithology, we have the rock classification scheme as well, but you can look that up for yourself. The lithostrat and the lexicon, they're the main things to go for. So if you get into the habit of describing rocks to other scientists or to people asking you questions about the geology, if you can understand a bit of lithostratigraphy and if you can work your way around a very old web system, you've pretty much got it covered for describing geology to friends and colleagues for the next 25 years of your career. Onto the last slide, so hopefully there'll be enough time for some questions in a minute. Every year I try and point out what maps are available to you. Every year I try and point out what I think you might be doing with those maps, or I hope you've been asked to do with those maps. I'm hoping it's not just some horrible homework that you didn't want to do and wasn't expecting. For BGS, this is a list of what's been happening utilizing some of the data that I've just shown you. So this data is used in anger every day. I've just stepped into this presentation having given another presentation to some people from government to do with hazard reporting for road networks in the UK. Biggest thing this year has been radon reporting because we hadn't released that map for 11 years. We hadn't created a new version of that map. There's been a lot of traffic over why has the map changed? What does it mean? There's a lot of support that has to go into this, which is why we still need to hire geologists and scientists and specialists, because these things don't change. Just because things drop off the news headlines doesn't mean these issues go away. So radon has taken up about 15 to 20% of my time this year. And I know that my statistician who made the radon data set has been 100% allocated to support duties for people using the data set. The other one, which is coming up, and I'm hoping if you're doing studies at university or if you're doing research, I'm hoping you're looking at ground source heat. So net zero targets for public buildings are very much in vogue. And ground source heat has had yet another resurgence. I think this is the second or third iteration of ground source heat in my career over 30 years. Ground source heat is back in the game. We'll have some new products for ground source heat. I'm going to ask the Adina family to very kindly, if they take a few of these on, I'm hoping to make them freely available. These would be great for people who want to look at a geological resource which is largely untapped in the UK but could have a fundamental impact on net zero targets. You can find out more about this online, but hopefully we'll get some new data sets that Adina can drag into Rome and you can play with next year, maybe a bit later. Aquifer protection come up again. Aquifers, as I said earlier, they come round regularly. Everyone forgets about them, and then all of a sudden something changes in legislation. All of a sudden people need to know, oh, we need to know about the Schedule 1 aquifers. What have you got for that? You can actually find that information out from the data set that I've just shown you. And it's been a really busy year for road improvements. So if you are currently looking for internships or placements, if this is your final year, there's an awful lot of road work and network rail work going on where an understanding of geology and hazards would be really handy. So good idea to brush up on looking at these maps in Adina and Rome. EV charging points has caused no end of trouble. If someone's got a really easy solution for how we get this right, I would say you'd be pushing at an open door for a career in designing these things. We need a lot more of these. All kinds of geology information goes into where you site these and how you make them resilient for climate change. Fill your boots. There's a whole market on there. They have made my life a misery this year for reasons I won't go into. Offshore wind, despite the licensing round not going quite to plan, offshore wind is still super critical for UK. Understanding the offshore environment is really important. Yes, those companies really do use the 250K data set that I showed you just now that you have access to. Obviously, they do a bit more research because those turbines are quite expensive and they have to design each foundation. But the reality is that they start with that map. So if you can understand that map, that's your foot in the door to that sector. Again, like offshore wind for the renewables, reactive waste and new nuclear, a constant flow of information between BGS and organizations interested in that. New nuclear are these modular systems, these microsystems that they're looking at as a way of working up alternative nuclear resources for the future. And the management of the waste of those, of course, which is an ongoing, I mean, I've been looking at radioactive waste since day one, 33 years ago for me. You might see some traffic about buried infrastructure. People are only just become aware that if you start putting things in the ground and forgetting about them, they have a nasty habit of surprising you. So buried infrastructure, it's down at the bottom at the moment, but I suspect it will start to creep up. As time goes on, climate change has an impact on the shallow subsurface. You'll see buried infrastructure failures being looked at more closely. Again, if you're interested in the shallow subsurface as a geologist or a geographer, good idea to go and become familiar with the basic geology. Also have a look at the anthropogenic layer because it's an understanding of where our assets sit. Do they sit in geology or do they sit in a man-made material that we've put into geology? And then last but not least, we've had a steady trickle of brownfield reuse. We've got a housing need, we've got brownfields, we need to put the two together. It's something that I know professionally we've failed to do for at least 30 years now. We do need to resolve that. So these are the things that are currently active. All of these things on the screen at the moment use the maps that you saw on the previous screen. I am happy to take any questions, so I'm going to stop sharing now.